So the diagram here shows that we have ourselves a square. It's inscribed within a circle. Inscribed means that it's completely contained within the circle. Or another way to say it is that the circle circumscribes the square. And the question is, how many times greater is the area of the circle compared to the area of the square? So obviously we need to be able to find the area of both of these. So the area of a circle is just pi r squared, and that's supposed to be a 2. You can see clearly that we have ourselves a radius. That's the radius of the circle. However, as far as what the area of the square is, maybe that's a little bit tricky. So notice that if I just look at one of these little right triangles, the green right triangles, we can just use the Pythagorean theorem on it. So here's the right triangle. Each one of these sides is r. And I'm just going to say that this side right here is s. I don't know what it is. So I'm going to solve for what s is using the Pythagorean theorem. So s squared should be equal to r squared plus r squared, right? It's like a squared plus b squared equals rc squared. Okay, now just simplifying these, I have 2 of these r squareds over here on the right side, so s squared is equal to 2r squared. And now I'm going to stop right there because s squared, if this is the side length of the square right here, that's the area of the square, right? So this is area of the square. Now if I want to know how many times bigger the circle is compared to the square, I'm just going to divide those two things. So I'll put the circle on top. That looks marvelous. It's like my son wrote it. Okay, over square. And so I have pi r squared over 2r squared. And you can see that these r squareds will cancel out. Now, they'll cancel out as long as they're not 0, because you can't divide by 0. But hey, if your radius is 0, you're not even doing a problem here. You don't even have a circle. So we're left with pi over 2. So the area of the circle is pi over 2 times greater than the area of the green square.